In this video, I'd like to talk about the math question of the day for Saturday, June 3rd, 2023. And with this question, we are given a function, and we need to evaluate these limits at infinity and negative infinity. We'll take the limit as x approaches infinity of our function, and we'll do the same when we take the limit as x approaches negative infinity of our function. And limits at infinity are typically taught in a Calculus 1 class, usually early on in the class. So at this point, go ahead and pause the video, see if you can work through this on your own. And when you're ready, unpause the video and we can go through this together. Now, assuming that you have attempted the problem, let's start working through this. And there are a couple approaches. We could actually just think through what happens as we look at bigger and bigger x values, or more and more negative x values, or we can take a more algebraic approach. We can look at our numerator and denominator and determine what is the highest power of x between these. And we can see that is x to the fifth. And from here, let's multiply both the top and the bottom by the reciprocal of x to the fifth, namely by 1 over x to the fifth. And we'll do this in the top and the bottom. That way we're really just multiplying everything by 1 here. And from here we can rewrite our function so that we will now distribute x cubed multiplied by 1 over x to the fifth. That would just be 1 over x squared. Then we get minus 2x multiplied by this. One of the x's will cancel. We get 2 over x to the fourth, and then 11 multiplied by this. The 11 would just go in the numerator, and that will be divided by x to the fifth. In the denominator, we will have 3 multiplied by that, which is 3 over x to the fifth. And when we multiply minus 6x to the fifth multiplied by 1 over x to the fifth, all of the x's cancel out, and we just get minus 6. And from here, we can now take our limit, and it will be much simpler to take our limit as x approaches infinity, since all of these terms that are divided by some power of x will approach 0 as x approaches infinity, or as x approaches negative infinity. So let's evaluate that. We have the limit as x approaches infinity of our function. Well, this first term, as x gets bigger and bigger, the denominator will increase. In fact, that denominator will approach infinity. And since the numerator is fixed, this fraction as a whole will get smaller and smaller. So this will approach 0. And likewise, all of these will approach 0 since the numerators are fixed and the denominators just get bigger and bigger, meaning the fractions get smaller and smaller. So all of those approach 0, meaning that our entire numerator just becomes 0, and our denominator becomes 0 minus 6, which is negative 6. And of course, this will just simplify to 0. So the limit as x goes to infinity of our function is simply 0. And if we look at the limit as x approaches negative infinity, we'll see the exact same thing. With the even power terms, it will be identical since squaring a negative makes it positive. So we know for sure, based on the reasoning from this limit, that both of these will go to 0. But for these other terms, they will also approach 0, just in a slightly different way. This will be a very large negative value when we raise it to the fifth power, as we let x approach bigger and bigger negative values. And the numerator is still fixed, so we have some fixed numerator divided by some very large negative value. And since the numerator is fixed and the denominator just gets bigger and bigger, this will approach 0, but it just approaches it from the negative side, whereas these approach it from the positive direction. But it doesn't really matter. In both cases, they approach 0. And so this denominator will also approach 0, at least for this term. And again, it will approach it from the negative direction, but it will still go to 0. So as we take the limit, as x goes to minus infinity of our function, the numerator, again, will just become 0, and our denominator will be 0 minus 6, which is just negative 6, and 0 divided by anything is 0. Unless, of course, we are dividing by 0. 0 divided by 0 is a little bit more complicated, but 0 divided by almost anything is 0. And I did mention there is another way to think about this. We could just think this through rather than use this algebraic manipulation. But this manipulation does help make things a bit clearer and does prove that our work is correct. But let's just think it through. So let me make a little bit of space, and I'm going to rewrite our function in a slightly different form. We'll say that f of x is still this cubic polynomial in the numerator, but our denominator, I'm going to put the highest power term first so that it's written in standard form. And basically, as we let x get bigger and bigger or more and more negative, what happens is that the lower power terms matter less and less. Essentially, when, let's say, we're approaching infinity and we put in, let's say, 1,000,000. When we cube 1,000,000, that becomes a 1 followed by 18 zeros. That would be 10 to the 18th power. And then we're just going to subtract 2 multiplied by 1,000,000, or 2,000,000, which is minus 2 times 10 to the 6th, plus 11. And of course, this is just pertaining to when x is 1,000,000, and we're going to put in even bigger values from there. But when x is 1,000,000, we can appreciate that when we have 10 to the 18th power and we subtract 2,000,000 from that, subtracting 2,000,000 barely changes this number at all, since this is such a smaller number than 10 to the 18th power, or that 1 followed by 18 zeros. It will barely change the number at all, and then adding 11 to that changes it even less. It's essentially like adding 1, or I should say subtracting 2 from a quadrillion. Subtracting 2 from a quadrillion is still basically a quadrillion. So in other words, as x gets bigger and bigger, these lower power terms matter less and less, and essentially the only thing that matters is this x to the third power, at least in the numerator. And the same argument can be made for our denominator, though now we have an x to the fifth power term. So as x gets bigger and bigger, this constant matters less and less. So as x approaches infinity, our function starts tending towards the ratio of the highest powers in the numerator and denominator, this x cubed over minus 6x to the fifth. And from here, you can cancel some of these x's out. You can cancel 3 in the numerator and 3 in the denominator, so that you get 1 over minus 6x squared. And now, when we take this limit, as x gets bigger and bigger, notice that our numerator is fixed and our denominator just gets bigger and bigger. It will be negative, but it will get bigger and bigger, meaning this fraction will get smaller and smaller. And essentially, this will approach 0, but from the negative direction, though that doesn't really matter. The main point is that it approaches 0. And a similar argument could be made for when x approaches negative infinity. This function, again, you can think it through, will just approach 0. So this at least helps us think this through and confirm that our answers over here do in fact make sense.